Hi everyone, it's Caitlin here again. So by now you have come up with a list of the factors and processes that influence the survival of insects in Morrow Canyon. You've also narrowed that list down to the 10 to 12 things that you think have the biggest influence on our insects. Next, we want to take your list of factors and turn them into a model that can help us think more directly about our experiment, studying the different types of plants in restoration. Our model is going to address the specific question, how does planting water saver plants versus water spender plants affect the number of insects at the bowl? As you create a model, you'll be comparing two different conditions, areas seeded with water saver plants and areas seeded with water spender plants. So to create your model, you'll need something to draw on and something to draw with. You'll also want sticky notes and a pen or pencil to share your thinking as you go. You can use paper, poster board, markers, crayons, whatever you like. I'm going to demonstrate it here so that you can see how the process works. So to start, I want to draw my two conditions, an area planted with water saver plants and an area seeded with water spender plants. So to illustrate this, I'm going to draw a bush sunflower plant on one side to represent the water savers and a California sagebrush on the other side to represent the water spenders. I'm also going to label them water savers and water spenders. Next, I want to look at the list of biotic factors, abiotic factors, and processes and pick one of the items to add to your model. So one of the abiotic factors on my list was water in the soil. So I'm going to add that to my drawing here in the form of a few little water droplets. Once I've done that, I want to show an arrow showing how it affects any of the other parts of the ecosystem. So as I'm adding factors, I want to think about how they might interact with my water spender plants and my water saver plants. So I think that for my water saver plants, there's going to be an arrow coming up into the plant and out of the leaves. Same thing happening with my water spender plant. But with my water spenders, because they're spending more water, I'm going to draw a lot more arrows coming out. And one resulting difference here is then I think there's going to be less water left in the soil. So I'm going to draw more water droplets here with my water saver plant. Next, I want to use sticky notes to explain any differences that I see between my two different treatments. So I might say water savers take up less water and leave more in the soil. So every time you add a component or a process, you're just going to want to think about how it might be different between our water spender plot and our water saver plot and our water spender plot, and write down your thinking in a sticky note. Next, you want to add something biotic from your list. So I thought that the toughness of the leaves might affect our insects. So you can think about how this might vary between one plant type compared to the other. You can also try to draw what plant toughness looks like in this scenario or explain the differences on a sticky note. So I'll continue my drawing, adding elements to it until I've included all the important factors and processes. As you're adding factors, make sure that you're drawing arrows between all the parts of the system that you think might interact. Once I've satisfied that I've added all my factors to both sides of my model, it's time to decide where we would find more insects. So take a look at each side of the model and the differences you drew and the sticky notes explaining those differences, and decide where you think more insects are likely to be found. Then you can draw some insects in your model. So maybe in one side you might draw one or two insects, something with little wings here, maybe a little caterpillar. And you would decide if you want more on your water savers or your water spenders. All right, so now it's your turn. Go ahead and gather back with your research teammates and start drawing your model.